unit, but I'm actually going to start it at section 4.7, mainly because it does a really good job of taking the rules that you learned in Unit 3 and applying them to a specific case of evaluating limits. So you should think about this. So if you're thinking about L'Hopital's rule, okay, so this is you down here, here, okay, I don't know what you're doing, but that's you. Learning calculus, so you definitely have a smile on your face. You should be thinking about L'Hopital's rule when you go through and you do a limit as x goes to any value. It doesn't matter what the value is. And that limit produces 0 over 0 or infinity over infinity. If it produces either one of those, you should think, hey, I think I need to use L'Hopital's rule. So here's what L'Hopital's rule says. L'Hopital's rule says that if you have the limit as x goes to some value, whatever it is, and you have one function, f of x, divided by another function, g of x, if when you evaluate it, you get the indeterminate form 0 over 0 or infinity over infinity, then what you should do is this thing is equal to the limit as x goes to that same value, we aren't changing that value, f prime of x divided by g prime of x. So it's not a quotient rule or anything, you're just evaluating, taking the derivative of the top function divided by the derivative of the bottom function. Now, in order to use L'Hopital's rule, you have to establish that you get that 0 over 0 or infinity over infinity, but you've got to do it in a pretty specific way. And so it's something that I'll do my best to explain right now, and if you have questions, just ask. But that's the idea behind L'Hopital's rule right there. So it's the kind of thing that if I take this first one, and I take the limit as x goes towards -3, and I know how you love trig functions. If we looked at the limit as x goes towards -3, and we looked at the top function, what we would get is we'd get 3 times the sine of 2 times -3 plus 6, which is 3 times the sine of 0, which is 0. So if we establish that that's true, and the limit as x goes towards -3 of 3 plus x, which is just 3 plus -3, that equals 0. Because we got both of those, we can use L'Hopital's rule. And you really want to establish those as separate entities. So then we're going to use L'Hopital's rule. So our limit is equal to the limit as x goes towards -3. Now we have to differentiate the numerator. The derivative of the numerator is a process of using the chain rule. So we leave the 3 alone, differentiate the sine into cosine, leave the 2x plus 6 alone, and then differentiate the 2x plus 6, which is just 2. So that's the chain rule. And then if we take the derivative of the denominator, we just get 1. So if you notice now, as soon as I plug in -3, now I actually don't have an indeterminate form. I don't have that 0 over 0 or infinity over infinity. What I have now is I have 3 times the cosine of 0 times 2 divided by 1. The cosine of 0 is 1. So we have 6 over 1, which is just 6. And that's our answer. But we do need to do that work in blue, and we need to do it as separate limits, because if you start to put them together, what's going to happen is you're gonna write this indeterminate form 0 over 0, and you're going to write some equality things that just are not going to work out. They're not going to work out to your benefit. So it's okay to kind of think to yourself, when I think to myself on this particular one, on this first one, on this next problem here, if I think about it, I kind of go, okay, well, I know if I put in 3, I'll get 0 on the top, and if I put in 3 on the bottom, I will get 0, and I go, I'm going to use L'Hopital's rule. But if I'm answering it on a free response question, I want to make sure that I separate these out into 2 different limits, because you're going to write equality things that are not good mathematics if you don't, and AP will burn you on a free response question if you do that. So if you do this, you get, if you do this problem, you get 3 squared minus 3 times 3, which is 0. And then if you do the denominator, the limit as x goes towards 3 of 3e to the 2x minus 6 minus x, you'll get 3e to the 0 minus 3, which is 0. So we established that we can use L'Hopital's rule because we do get 0 over 0. So then what we can say is the limit that we have is equal to the limit as x goes towards 3. And then we want to differentiate the numerator and the denominator separately. So not using any kind of quotient rule, but this would be 2x minus 3. And if we differentiate the denominator, we are going to have to use the chain rule on that first part. So it would be 3e to the 2x minus 6 times 2. And then you do have minus 1 there. Now we're going to go back through and evaluate it and see what happens. What we're going to get now is if you put 3 in, you will get 0 on the top. And on the bottom, you'll get 3e 2 times 3 minus 6 times 2 minus 1, which is 0, divided by, that's going to be 5. And 0 divided by 5 is 0. So that's what that limit is. But we established the use of L'Hopital's rule using by separating the numerator and the denominator limits. And if you look back on your notes from Unit 1, that's a legal thing to do. You can establish looking at the limit of the numerator and the limit of the denominator to figure out the existence of a limit or not. Okay, so then you might have problems like this. This is similar to some of the problems in that exam that you just took, where if you where they throw a generic function in here. Notice that if I put 3 into this one, I do get 0 on the numerator, and if I put 3 in the denominator, 3 is right there. That's a slope of -1. I think it's -1. Yep, -1. Or that's actually a value of -3. So you get 0 on the bottom too. So you go, okay, well, shoot, now I have to use L'Hopital's rule. That's okay, because then what that means is we could, you probably want to establish that. So you want to write that out. You want to look and go, okay, the limit as x goes towards 3 of x squared minus 3x is equal to 0. And the limit as x goes towards 3 of 3 times f of x plus 3x also equals 0. So use L'Hopital's rule. Now we're going to use L'Hopital's rule. L'Hopital's rule says that this limit is equal to the limit as x goes towards 3. The numerator would be 2x minus 3, and the denominator would be 3 times f prime of x plus 3. So now let's see what happens when we plug in 3. We would get 2 times 3 minus 3 on the numerator. And on the denominator, we would have 3 times negative 1 plus 3. Now, if you look at this situation, this is undefined, because if you think about what's happened, and I'm not going to use arrows or equal sign because I'm gonna do that because I don't want to write something where I'm dividing. Notice I'm dividing by 0. Notice that this is 3 divided by 0. That means the limit does not exist. Remember, when you have a 0 on the denominator, you get does not exist. And I specifically used arrows in there, knowing that I could jump from this right to that one, but I wouldn't want to write that math in between, because this little thing over here is it should cause you concern, and you should go, wait a minute, I can't really write divided by 0 because that's an indeterminate form. It's undefined, so you write does not exist for the answer. I think there was one more example where I say, okay, well, let's do it with a table of values. Again, just kind of gauging what's happening. This is going to be f, just to see what happens, f of 2 times 1 minus 1 for the numerator, and then this is 5 minus 6 for the denominator. Well, wait a minute, that doesn't quite bode for the L'Hopital's rule, because f of 2 is right there. There's f of 2. So that means we have 3 minus 1 divided by 5 minus 6. So that's 2 over negative 1, which is negative 2. So this one, no L'Hopital's rule. We can just evaluate this. We could just say that the limit as x goes towards 1, f of 2x minus 1 divided by 5x minus 6x squared. If we just evaluate that, that's f of 2 minus 1 divided by 5 minus 6. F of 2 is 3 minus 1 divided by negative 1 is negative 2. And that one's done. So just because this is in L'Hopital's rules set of problems does not mean that you have to use L'Hopital's rule. I'm probably going to have you do like 7 of these problems. So don't freak out when you see that it's 7, but that's the only thing you have to do. But you do want to establish this. And if you're doing a free response question and you're going to use L'Hopital's rule, you do want to establish like what I did up here in blue. If L'Hopital's rule isn't applied, you could just evaluate it like we have all along. Hopefully that makes sense, and you'll have questions if you need help.